Right. Um, we got that right, and then the uncertainty is just half of your precision. Okay, there you go. And so the measurement therefore will be 17.20, right, plus or minus the uncertainty you just figured out. So from now on, when you add values, like you should first figure out the precision, the uncertainty, and then add or subtract as needed. Next, the thermometer here. Uh, the precision is 10, right? Is 10. If these had markings in between, then it would obviously be 5, right? So this is 10 degrees Celsius. And so the precision, uncertainty is half of that. And so we are at 20, right? 20 degrees Celsius plus or minus 5 degrees Celsius. Keep in mind, guys, that don't let that throw you off, because I could then ask, what's the maximum and minimum temperature, possible temperatures, right? So the max would be 20 plus 5, and the lowest possible temperature would be 20 minus 5, right? So there's a bit of an uncertainty there. Every single one of these you could actually do that with. You got to watch out when you do centimeters and millimeters, then maybe you need to convert one of them, right? Before you add and subtract. So just watch out for that. Here, the precision of this, I don't know if you figured this out, but just count, right? 1, 2, 3, 4, 5, 6, 7, 8. This is actually 1/8 of an inch. And the uncertainty, therefore, is 1/16 of an inch. It's half of an eighth. How else did you do it? A 0.125 of an inch. Like if you convert the eighths to decimals, that's fine. And then split this in half, right, to get the other one, to get your uncertainty. Measurement, so this here you have to be careful. I would say this would be 4/8, right? The middle is always half. This would be 4/8. So this is 5/8. So it'd be 5/8 of an inch plus or minus 1/16 of an inch. And you're like, Mr. Dirksen, there's a 5 there, right? Well, I know, but the line starts there, so it's really 5/8, almost 5/8 of an inch plus or minus some uncertainty. Right? I think I'll just fractions, like if it's like this, just leave it, right? Unless you feel strongly you need to convert, I'm okay with that, right? But if it's a quarter, then it would be 1/8, right? You just double the denominator. You're basically making it half as big, right? The chunk. So that's not precision here. Watch out. It's 100 divided by, there's 2 gaps, right? So it's actually 50. So it's 50 milliliters, and the uncertainty therefore is 25 milliliters. There's nothing in there, so you can't really give me a measurement plus or minus uncertainty, right? If there be something in there, then sure. Okay, so I hope you understand this. Explain the difference between tolerance and uncertainty. Uncertainty, it's caused by, anybody? What? The measuring tool. Limitations of the measuring tool. By the limitation of the measuring tool or instrument or whatever. Okay. The smaller the precision, guys, the smaller that number, the more precise that instrument is. So it's kind of counterintuitive, right? But a tolerance, right? It's set by the industry, right? Due to, right, human error, right? Human error, equipment malfunction, etc. I have an extensive on your in your notes. Oh, you can't see that. Sorry. in your notes you have this in there, right? The difference between, I talked about that yesterday, right? What else do we call uncertainty? Did you hear that? Zach, margin of error. Yeah, it is. Yeah, you're right. Of course. Margin of error. Yeah. Um, which one of the following is a tolerance? I need you to understand the difference, right? This is definitely which of the expressions. So there's more than one option, right? So this is definitely tolerance. Check. This is definitely tolerance. Do you recognize the format, right? You should recognize, okay, nominal plus or minus half the tolerance, max or min, right? That's the tolerance. Is this a tolerance? And the answer is no, because there's no half in front of it. So for us, this would not be, that's actually uncertainty, right? Sorry, this one, uncertain, so tolerance, sorry, tolerance, uncertainty. Okay. Tolerance, uncertainty. Keep going. Let's see how you did with this one. Okay, so the max, remember you add them up. So this is 1.27 kilometers. Min, you just subtract, which is 1.21 kilometers. Nominal is what? Always the front number, okay? So it's 1.21 kilometers. Tolerance, how would you find the tolerance given this? I would subtract these two. In this case, it's actually 0.06. But if you subtract the max and the min, right, max minus min, you get it every single time, okay? You will, without fail, you will get that right, okay? Next, we have our max, which is 2 point, I don't know if you did the work on this. I'm expecting you to do this. Find half of that, right? So it'd be 2.75 would be your max. Your min would be 2.25. Your nominal, it's just the front number, okay? It's always that front number. The tolerance is actually right in the brackets. But if you weren't sure, if you subtract these two, you get your tolerance every time. Plus or minus half of that is 0.35, right? So to get the max, you're going to help me out here. 7.2. No, wait. I'm getting this wrong. Place value, right? This would be 4044, because the 3 turns into a 4 because the 5 and the 9 is 14. Yes, there we go. This is 6.74. Okay, so subtract. And then the nominal is just the 7.090 of an inch. Tolerance, you subtract these two or you just grab it from the bracket. Either way is fine. Okay. Here the max you just add. So let me just go 1, 2, 3, 4 decimal places. So that'll, the 6 will add to that, right? So 0.18, sorry, 0.186 meters. Okay, and then the minimum is we subtract here, right? So it'd be 0.0172 meters. Nominal is just that front number, meters. And tolerance, here you have to watch out, right? Tolerance, you have to subtract these two. And what is our tolerance? Is that 14 like this meters? Are we good? Or am I getting it wrong? I'm just going to add these two here. That is 14. 0, 0, 14, right? Subtract max and min, you'll get it every time. This is the weird looking one where you have, normally you're used to having a 0 on one of these. In this case, you don't, right? So I basically just subtract these two to get that. Max is just that because you don't add anything. To subtract that would be 0.040. The nominal is just the front number, right? That big number. And tolerance, you subtract these two. But in this case, because there's a 0, I can just go ahead and grab this and state it like that. So hopefully you got this right. Remember, if I get you to do this, you can technically write it in all the other forms, right? Okay. Given that the tolerance for a pipe is this, find the following. So half of this is 0.0125. That's if I split this in half, then I get that, right? So to get the minimum, we're going to go this minus that. Okay. So I'm gonna show the work here. 97.8 minus 0.0125, and this would be 97.8 plus 0.125. The tolerance I can just state it's already in the brackets. The nominal I can just state no math needed there. Okay. So this one would be 97. Sorry, I'm getting this wrong, right? I forgot this 0 here. Make sure you add that 0 in there. So that would be 97 point, isn't it 8125? Or did I get it wrong? Right, because if I get that, if I go plus 97.8, it's 8125, right? So we got to be very careful with our decimal place values, right? And that's because at first I didn't have that 0. That's very important. Let me zoom into that. It's very small. And then the minus, it's basically Friday, right? So I got to watch out what I'm doing here. 97.7875, and I am in millimeters. So I have to subtract that. So now you have, this is the recipe you need to figure out the other formats. So let's go ahead and do that. Max and min. So I just grab these two and just stack them, right? 97.8125 millimeters, and the min is 97.7875 millimeters. Okay. Why does he have to use weird numbers like that? Why, right? Well, I want you to make sure you understand, right? Like that's actually where this tolerance, these concepts are mostly used in that, right? So the max is 97.8125 millimeters. We're going to add nothing, but we're going to subtract the tolerance. The tolerance is right here. So you just follow this format, right? So we have it in the first and the second, and now the last one is min minus 0 plus tolerance, 0.025 of a millimeter. Sorry, you can't see that. Let me just zoom out for a bit. So there you have them. how would you define nominal? It is the hangman. Let's play hangman. There is no L. You should always try your vowels first. It is the target value. The target, that's what you're really aiming for, right? Nominal is what you're aiming for. So, just to make it very clear, these three here, this one, see where my pencil is up here? This one, and this one tell you, hey, we're aiming for that big number in front. That's what we're aiming for. The only one that doesn't do that is this. Okay. So keep that in mind. I think that's it for this workbook. And this will help you with certain things. So try to just listen and take in some of the things that I mentioned. So I will say this, guys. This is a weird unit. It is weird, but don't say I cannot do anything. I'll get it all wrong. Okay, that's not true. You can actually score a significant amount if you just read carefully and say, what is it asking, right? Remember that accuracy is affected by two things. What are they? Improper use of the measuring device, or a defective like a measuring device that has defects. Okay, this would be it's a defective measuring device, so it affects accuracy the most. But regardless, it affects accuracy the most in this case. Listen. If I ask you, guys, if it asks you, so I'm going to answer your question. If it asks you, somebody measured something and got it wrong, you can talk about that person not using it properly, or that the device may have been damaged. You just talk about one of them. One last thing, guys. The precision is 50 for the first one, 100 for the second one. Does that make sense? I hope so. Cylinder A wins this one because it has a smaller increment. It goes up by 50 at a time from marking to marking. Okay? So just watch out there. Guys, just wait. The bell's almost going to go. Until then, I have the stage. Precision here is 2 liters, right? Because you go up by 2. Half of that is your uncertainty. You got that? Backside. My precision is 0.2 because it goes up by 0.2 of a liter. Uncertainty is 0.1. Okay? This one is the one I need you to understand. Okay? You need to add 12 liters of water to a container. Okay? Calculate the total uncertainty of the measurement. Guys, total uncertainty. You have to understand that if you're using this 12 times, every single time it will have this uncertainty. It doesn't matter how much you measure, it will have this uncertainty. So you're basically adding this uncertainty 12 times because you're using it 12 times. You're using this to measure something 12 times. So basically you take the times that it has been used times the uncertainty. So this is what it's asking. That's the only thing it's asking for, the total combined uncertainty. Next here, the fencing question. This is an old exam question, by the way. they give you the uncertainty here. So you just stack them like this. No need to figure out the precision and uncertainty because it's already provided. You just add up both here. So you get 111 plus or minus 2 feet. But from there, you can get your maximum, but you could also get the minimum. Just read the question carefully. It asks for the maximum length. So this was, there was some extra work that needed to be done. First, add them up, then add your uncertainty to that value to get the 113. The next one, this might have been a little confusing, but tolerance, in a sense, the tolerance is the difference between the max and the min. So if I give you the max, you subtract the tolerance, 0.007, to get the min. Any value that fits in between here is acceptable, including obviously these two numbers. So one last thing here. The only one that is permissible in this case would be that number, because watch, 15.091 is just over this. It doesn't pass the test. This one is 15.078. It's just over. This is 77, 78 is somewhere in here. This would pass the test. 98 is somewhere above that, right? So this doesn't pass. 1570 is short of the minimum, right? Doesn't pass the test. This is the only one that does. I will scan both this one and the other one and post it. Maybe I'll put it on the video here as well. The other one's AC4. There it is. If you want to practice,